Alright, here we are. I'm just going to do the first problem with you, show you how simple this is. As long as you remember these three simple values, 34, 13.5, and 2.35, you're going to be very good. All of these problems are assuming that you've got a normal distribution of data. It doesn't work if that is not true. So we're assuming that is true. It usually is when you give tests or measure people or something like that. So in this case, we've measured people by giving them a French quiz. The average score was 37 and the standard deviation is 7 points. That's the critical thing that tells you how spread out the data is. The middle value, this X bar value, is 37. That means 50% scored above a 37, 50% scored below the 37. We then measure off in standard deviations. This is X bar plus 1 standard deviation, means that's 37 plus 7 is 44. 44 plus another 7 is 51, plus another 7 is 58. Draw those three lines. 7 minus 37 is 30. 7 more minus 30 is 23, and I should show that even 7 more is 16 right there. So now these percentages that you've memorized can be filled in. There goes 34. This one is also 13.5, and this one here, that little value is 2.35. Okay? So now to answer these questions, it's really simple. What percentage, approximately, what percentage is between 30 and 37? Well, between 30 right here and 37 right there, that's this percentage. Well, that's very simply 34%. Okay, that's what that means. So what percentage is between a 23 and a 37? Well, that's from here up to 37. So that's 34 plus this percentage. 34 plus 13.5 is 47.5. 47.5%. Because why? Because it's 34 plus 13.5 are two numbers that describe these partitions, these divisions of our bell-shaped curve. What percentage are between 37 and 44? So between 37 and 44, that's just on this side. So this is also 34%, okay? And then approximately what percentage scored below a 30? So if this is 50% on this upper half, and this represents 34%, then going this way is what's left over. All right, well, 50 plus 34, that's 84. Take that away from 100, and it's 16%. Now, you could also say it's 13.5 plus 2.35, but there's actually a really, really little sliver that goes way down here. So it's more accurate to think of the way I did it in the first place, which is add these two and subtract that from 100. All right? You won't get it totally wrong if you add up, but you'll just be missing this little 0.65% out there. Then here's where we get to real numbers. If there were 26 students in the French class, about how many of them scored below a 23? Well, that's going to be the percent that's 2.35 plus this little bit. That's going to be 2.5%. 2.5%, but then times 26 kids in the class. All right. So what's that going to be? Take out your calculator and multiply that. That's going to be in percent. That's going to be 0.025. 0.025. It's going to be approximately 4 and a little bit. So it's going to be not even a whole student. So you'd maybe round it to the nearest one student. All right. So I'll let you do the calculations on that, but just round it to the nearest student, or you could say a fraction of a student. That's okay, because mathematically that's what it's saying. All right. Good luck.